Okay, let us continue. Along the vertical path, that is along OY, here acceleration along y is nothing but -3. And let me write the equation of motion by using s is equals to ut plus of at square. What I can write along y axis. So I can write as y is equals to uyt plus half ay t square. Isn't it? This is nothing but equation of one of equation of motion. S is equals to ut plus of at square. Instead of that, I have given y, and so ut along y direction velocity. Ay means acceleration along y axis. So along y direction, vertical direction. Now, so here what we have the value of uy. We know that along vertical path uy is nothing but u sine theta, and now ay is already written. So let me write the value of uy, that is nothing but u sine theta into t. So plus half. What is the value of ay? Ay is nothing but, we know acceleration is -3 into t square. Okay, so this can be written as u sine theta into t minus half g t square. Okay, so now take it as equation 1. So this is what equation for vertical motion. And now let us see what happens along horizontal direction. Along horizontal, we can study the equation of motion as, instead of y, what I can take, that is x. So x is equals to, instead of uy, what I can write, ux into t. And we know that along the horizontal acceleration is 0. So the equation will be x is equals to ux into t. So what is the value of ux? What is the component of velocity along x direction? That is u cos theta. So let me write ux as u cos theta into t. Okay. So now what is the value of t? Here this can be written as t is equals to x by u cos theta. So t equals to x divided by u cos theta. Okay. Now substitute this in equation 1. So let me keep t value in equation 1. So what it will become? So y is equals to, equation 1 becomes y is equals to u sine theta, and value of t is nothing but x divided by u cos theta, and minus 1 by 2 g as it is t square is nothing but x by u cos theta whole square. Right now, x by u cos theta whole square. Okay. So now, what will be the next step? Look at this. Y equals to, just simplifying, u and u get cancelled. Sin theta by cos theta can be written as, tan theta into x minus 1 by 2 g x square divided by u square cos square theta. So squaring that t value, x by u cos theta whole square is x square by u square cos square theta, isn't it? Now look at this equation. Isn't it in the form of y is equals to ax plus bx square? So where a is equals to tan theta for x as it is variable as it is, for a value is given by tan theta, and now so here b value is given by minus 1 by 2 g u square cos square theta. Just take x square one side. What is remaining instead of b over here? So b is nothing but, you can take minus 1 by 2 g u square cos square theta. It is what? B. And here it is nothing but a. So isn't it in the form of y is equals to ax plus bx square? So as it is similar to the equation y equals to ax plus bx square, we call the path of a projectile as a parabola, which gives you that the trajectory of a projectile is a parabola. So here, so this is what the most important topic, which has been asked for 5 marks many times. Okay. So I hope it is clear to everyone. So let me revise it in 1 minute. See what we have to write at first. So consider a projectile which is projected with initial velocity u at an angle theta with the horizontal direction, isn't it? No. So here the horizontal component of velocity is nothing but ux is equals to u cos theta, and vertical component is uy is equals to u sin theta. No. So they all, as it is moving under gravity only, the acceleration will be along vertical. That is acceleration ay is equals to minus g if I take upward direction as positive. So the downward acceleration is minus g. Now, so what is the acceleration acting along the horizontal direction? That is 0. Why? Because there is no any force which is giving acceleration to the motion of the body along horizontal direction. So that's why ax is equals to 0. Now, so what we have to write? We have to just write the equations along x and y direction. As said you, for plane we are just writing individual equations as one dimension equations. Now, along the path OY, what you can write the equation of motion as y is equals to uyt plus half ayt square, and you know the value of uy, that is nothing but with what velocity? Here it is given as vertical. Y is nothing but vertical acceleration is minus t and t square as it is. Now, so u sin theta into t, take this minus here, minus half j square, take it as equation 1. So here we done with vertical motion. Okay, now, so along horizontal, so motion along the horizontal direction, along OX. So horizontal means what? Along OX. Now, the equation of motion is nothing but as there is no any acceleration along the horizontal direction, what you can write x is equals to, instead of y, x is equals to ux. Okay, so now ux is nothing but the velocity along x direction, that is horizontal component of velocity u cos theta into t. So what is the value of t? T is equals to x divided by u cos theta. Okay, so now keeping this equation of time, that is value of time in equation 1, we got t as x by u cos theta. So substitute in equation 1, what we will get? Wherever t is there, just write down x by u cos theta. Okay, so now t square, x by u cos theta whole square here. So t is replaced by x by u cos theta. Now, so simplified again, u by u get cancelled, sin theta by cos theta can be written as tan theta minus half g x square by u square cos square theta. And this is in the form of standard equation of parabola, that is y is equals to ax plus bx square, isn't it? So keep the variables as it is x, what is remaining? A is represented by tan theta. Instead of a, here we have tan theta, instead of b, here we have minus 1 by 2 g u square cos square theta. Okay, so this is how we can say that the trajectory of a projectile, what is trajectory? The path followed by the projectile is nothing but a parabola. So this is for finance. So now we will move to next. Yes, see, I said already, I have given one example initially for projectile motion, that is nothing but when the cannon is firing the man, that means instead of ball, if the cannon is firing man, we have seen in the circus, so that man will be caught by the net which is placed far away from the cannon at some particular distance from the cannon. It is not like that wherever we want we can keep the net. It is not like that. There should be some calculation at what distance from the cannon the net should be placed. Okay, so that means that is nothing but here you can see if the body is projected from here means if net is placed here means we can caught the body, isn't it? So we can catch the body over here and the body has caught by net. Now you see, so this is what the distance from the point of projection. This is what the distance from the point of projection where the net has to be placed, isn't it? So here at this end point, okay, where it falls down, here where we have to keep the net, isn't it? So then only we can catch the body, isn't it? So the thing is, we should have some calculation. How to calculate? At what distance actually we have to place the net? At distance called r, and how to find out r? So what should be that distance to catch the man, otherwise to catch any ball over here, what should be the distance at which we have to stand? Okay, so that is what the horizontal distance are. Okay, now just let us suppose that you are throwing a ball in the room at a certain angle from the horizontal, you are throwing the ball. Now, if you don't want to hit that ball to ceiling, isn't it? So if you don't want that ball to hit the ceiling at that time, what you should know, that means at what height the ball can just reach, isn't it? So at what certain maximum height the ball will reach, so that it should not hit the ceiling, so like that. So for that we need the value of h, isn't it? So how to find out the value of h and how to find out the value of r? And next thing is, and one more thing, okay, just imagine you are somewhere at far distance from the point of projection. You are far away from the point of projection, and you just want to catch the ball, and you have to run over here. So at what time, within what time the ball can be caught by you? Okay, so that means at what time, up to what time the ball can be there in the air. That means what is the time of flight of a projectile? So what is time of flight? That means time of flight is nothing but the total time up to which the body is remaining in the air, the projectile remains in the air. Getting? So here where you have thrown the projectile, from here to here, so from the point of projection till it hits the ground, what is the time up to which the body is remaining in air? So throughout its motion. So that is what called as time of flight. That time of flight is denoted by capital T. So what it should be? How long the body can be there in air? So that we should know. So what is the value of T? Isn't it time of flight? Now, if the body is moving from the point of projection, let us say, if we are considering a projectile motion, the body is moving from the point of projection, and now how much time it takes to reach the maximum height? So what is the time taken by the projectile to reach the maximum height? So here, this is what the maximum height. So to travel from point of projection to maximum height, what is the time needed? Small t. So that is what called as time of ascent. So how much time the projectile takes to reach the maximum height, to reach the maximum height during its motion. That is what time of ascent. Okay. So what is that value of small t? I know how much time it takes to come down again. So from maximum, see here, from the certain maximum height to again it has to fall down where y becomes 0. So here what you can say, again what is the time of descent? This is what called as time of descent. That is nothing but t. And here again time of ascent. Here you can notice for both I have written small t only. Why? Because the time of ascent will be equal to time of descent. Okay, so now here we have to find out. In next class we will deal with what is the value of maximum height the projectile can reach, and what is the value of horizontal distance the projectile can have its motion, and what is the value of time of flight, that means how long the projectile can remain in air. Okay, so what is the time of flight, that is capital T, and what is time of ascent and time of descent? All these things we will discuss in next class. I hope that today's class is clear to everyone. Just glance, just go through the derivation once. This is for 5 marks. And tomorrow we will continue the next thing. If you have any doubts, you can ask now. horizontal. The horizontal distance covered by the body is r. See here, we are studying the motion of a body under plane. Okay, so in a plane, it will be covering both x and y axis, isn't it? So along the horizontal, the distance covered is r. Okay, so that is r. Along the vertical, how much distance it can travel? That is h. So as you can see, listen, everywhere. So if I take point P over here, so at a point P here, the somewhat the distance horizontal and vertical distance will be x1 comma y1 like this. Okay. So here P dash of x dash, sorry, x1, x2 comma y2. Here at this point the horizontal distance covered is different, and here at this point the vertical distance covered is different. Okay. So the total distance we can find out the total distance how much it is covered here. Standard expression that is r horizontal distance, and here it is vertical distance. Vertical distance is nothing but the maximum height, how much it has covered, that is h. So for this we have expressions that we will take tomorrow. Okay. So listen here, as I have said earlier, so here we are taking along x-axis the component of u as cos theta. So u cos theta, why it is cos theta? See here, where there is angle. So theta is made with the x direction, isn't it? So the angle here between the u and the x direction is there. So this we take it as cos theta, and this side we take it as sin theta, the remaining side. If not, if there is angle over here, so that means the velocity is making an angle theta with the vertical direction. This you can take it as cos theta. Here it becomes cos, and here it becomes sin, isn't it? So now this is how I have taken. So you have to understand this. With what direction it is making an angle? Theta. So that is taken as cos, and here it is taken as sine. If I have taken the velocity of projection of a body, if this velocity vector is making an angle theta with the vertical, then I have to take this along this vertical direction instead of this. Here it is making an angle theta. If I know this theta, I have to write here u cos theta, and here it will be u sin theta. Okay. So now see, listen here. Along x-axis, I said velocity is remaining constant. Velocity component remains constant. Why? Because there is no any force acting along x direction throughout the motion of the body to produce acceleration, isn't it? So when there is change, as there is no acceleration, there is no any change in the velocity. So we say here the along x direction, the velocity component remains constant vertically as it is changing heights. So as it is changing heights over here, so as it moves up and up and up, potential energy increases, so that kinetic energy will be decreasing, velocity will be decreasing. As I mean, finally it reaches to the value 0 at the maximum height, and again it comes back. So while coming back, the velocity again increases, and it comes to the value with what it is projected. Okay. See here, as I said you, for a plane, we will split the components y and x. So that means the motion of a body along a plane can be studied as by taking the one-dimensional equation along y-axis for y-axis and how much it is covered distance along x-axis. We will take the equations along x-axis. I said you already. So that only we have written vx, vy, isn't it? So like that, the acceleration acting along the vertical direction. So along y-axis is nothing but acceleration due to gravity. Why? Because it is known that the acceleration due to gravity always acts along the vertical direction. Okay. So if you are taking acceleration upward as positive, downward it will be negative. Okay. So throughout its motion, the acceleration acting on the body is vertically acting is nothing but it is minus g downward. Okay, now, so along its horizontal direction, there is no any acceleration, okay, produced along the horizontal direction. Why? Because along horizontal there is no any force. As I said earlier, so gravity is nothing but the force acting on the body, which acts always vertically down, isn't it? So now there is no any horizontal force acting on the body throughout its motion. So there is no any acceleration acting on the body. So as there is no any acceleration, the component of velocity along x-axis will be constant and the acceleration along x-axis is 0. Okay, as there is no any force. And here, for studying projectile motion, as we are studying under kinematics, we are just neglecting the air resistance, other forces. Okay. See, listen here. If we are considering the projectile motion of a body, okay, listen. So this is what the horizontal direction, okay. The projectile is thrown by making an angle theta, okay. So the direction of motion of a projectile will be making an angle theta with the horizontal direction. So here, like this, the projectile will be moving. When you throw it by making certain angle, like this, the projectile will be moving, isn't it? So the same motion, instead of looking by side view, if you are just looking at this by taking, see here, if you are just taking view from the top, this motion, okay. So here this motion, if you are taking view of this motion from the top, that means like this. Okay, if you are taking like this, as what you can see is the body is moving along the horizontal direction only. What you can see is the body is moving along horizontal direction only. Now, the same motion, if you are taking like this, if you are viewing the same motion, projectile motion like this, okay, so like this, front view, it is what called as front view. So here, what you can see is the body is moving along vertical direction, like this, along y-axis. So when you take top view, when the projectile is moving like this, what you can observe is it looks like as if it is moving along the horizontal direction. Okay, so we take x-axis equations. Okay, so when you just view that projectile motion from front view, okay, what you can see is the body is moving up and down like this. Okay, so along vertically, otherwise along y-axis, the body is possessing its motion. So there again we are taking the equation of motions for y-axis along vertical axis. Okay.